let's take a look at the cube root of 16 times x cubed times y to the 8th times z to the 4th. Now before we really take a look at doing an answer, I'm going to suggest we do the following. Whoops, not square. Cube. Something cubed, and something cubed, something cubed. Okay, and through the power of pausing the recording, I sped things up a bit, but I'm going to stick here 1, inside the parentheses 1, 2, 3, 4, 5, 6, and then here a to the 1, a to the 2, a to the 3, a to the 4, a to the 5, a to the 6. Now, in this space there, where I've circled in green and there, I'd like you to fill in these spots because these are the things that are perfect cubes. Just like perfect squares are the results of squaring something, perfect cubes are the results of cubing something. So please pause for a moment and try filling those in. So 1, 8, 27, 64, 125, 216. I did use a calculator for 6 cubed there. A cubed, a to the 6th, a to the 9th, a to the 12th, a to the 15th, a to the 18th, and so on. These things continue, of course. In the case you have a base and an exponent, you're looking for that exponent to be a multiple of 3. So coming back here to the problem, cube root of, well look, 16 isn't a perfect cube. It's not in our list, but we want to ask, is there a factor of 16 that is a perfect cube? And that is 8. So we can rewrite the 16 as 8 times 2. For x cubed, it's already in our list. I mean, I know the variable's a here, but same deal, right? So a cubed is in our list, so x cubed would have been in our list had we put x to the 1 there, right? So we'll just keep that x cubed. That's already a perfect cube. Y to the 8th, take a look at our list. Ooh, y to the 6th would have been a perfect cube. Y to the 9th would have been. So how should we rewrite y to the 8th? Well, as y to the 6th times y to the 2nd. Finally, for z to the 4th, that's not in our list. I mean, there's z to the 3rd and z to the 6th. Z to the 4th was missed here. So to write z to the 4th as a perfect cube part and a non-perfect cube part, so the z cubed times z to the 1. Okay. So now let's just shuffle inside the radical all the things that are multiplied together. We can shuffle the order. I'll get the perfect cubes written first. So that's 8, that's x cubed, that's y to the 6th, that's z cubed. And then the stuff that is not perfect cube is this 2, and then y squared, and this z to the first I'm just going to write as a single z. Now I kind of didn't write all these time signs in between, but we can split at any multiplication we want, including here and there, but we won't here or there. All this fluff that doesn't have any perfect cube we'll just leave in one radical. The other stuff will split up. Some people feel comfortable skipping this step, but I feel like showing it in a video. Cube root of 8 times cube root of x cubed times cube root of y to the 6th times cube root of z to the 3rd times cube root of 2y squared z. So cube root of 8 is 2. I mean, what we're reporting on is the thingy that's in the parentheses here. Cube root of x cubed is x, or x to the first. We're really reporting on what's in parentheses here, the a to the 1, or, well, change the variable, but x. Cube root of y to the 6th is y squared. So same deal, that y to the 6th that's in the radical. I'm looking at this a to the 6th and saying, reporting on what's just inside the parentheses, y squared, if you will. I mean, instead of a squared. And same deal for the cube root of z cubed, that will be z. And then the rest of this stuff, cube root of 2y squared z. Let me make sure that radical is long enough.